Hey everyone, welcome back. It seems like everywhere you turn these days, it's all about data, right?
Yeah, it really does.
But have you ever stopped to think about how all that information is actually like organized and used?
Right.
That's exactly what we're diving into today.
Yeah.
We're talking all about database management systems, or DBMS for short.
Yes.
You sent over a really interesting source for this deep dive, a whole PDF packed with DBMS interview questions.
Oh, yeah.
Now, before you panic and think, wait, I'm not applying for a job, don't worry.
Right.
These questions are actually a super helpful way to break down those core database concepts, kind of like a cheat sheet.
Absolutely.
It's like, ever wonder how websites seem to remember all your preferences?
Yeah, it's pretty amazing.
Or how companies keep track of all their inventory without losing their minds? I bet there's a database working its magic behind the scenes.
Definitely. Databases are everywhere.
So let's start with the super basics, like square one.
Okay.
What exactly is a database?
Well, imagine a really, really well-organized spreadsheet.
Okay.
That's the easiest way to picture a database. It's basically a collection of information, or data, but structured in a way that makes it super easy to access, manage, and analyze.
Okay, so it's more than just a random jumble of files on my computer. There's like a method to the madness.
Yes, and that method is where database management systems, or DBMS, come in.
Okay.
Now, this is the software that acts as the brains of the operation.
The brains, huh?
Yeah, it lets us talk to the database, create stuff, retrieve information, update things, basically do whatever we need with that information.
So if the database is like a filing cabinet,
Yeah.
then the DBMS is like the super organized librarian who knows where everything is and how to find it.
I like that analogy.
And to make things even more interesting for our deep dive, we're focusing on a specific type of DDMS called RDBMS,
Right.
Relational Database Management Systems.
Yes.
Okay, relational. Does that mean the database, has feelings?
Not quite.
Yeah.
Think of it like building connections between different spreadsheets,
Mm.
RDBMS organizes data into tables, kind of like spreadsheets with their rows and columns.
Right.
But here's the cool part. It also lets you link these tables through, relationships.
Okay.
So, for example, you could have a table with all your customer information
Right.
and then link that to another table with all their orders,
Yeah.
It creates this much more complete picture.
Okay, so it's like connecting the dots between different pieces of information.
Exactly. It's way more powerful than just having a bunch of separate spreadsheets.
That's definitely starting to make sense.
Mm-hmm.
But how do we actually talk to these RDBMS systems? It's not like we just, have a casual chat with them, right?
Right?
Right.
We need a specific language to communicate.
Yeah.
And that's where SQL comes, in structured query language.
SQL.
It's the universal language for talking to RDBMS.
So SQL is our way of asking the database specific questions or telling it to do certain things.
Exactly. It's how we ask things like, show me all the customers who made a purchase last month, or update this customer's address.
Gotcha. It's like giving the database instructions.
Precisely.
But, and maybe this is just me, but I always get a little tripped up by the difference between SQL and MySQL.
Oh, yeah, that's a super common confusion.
They sound so similar.
Right, so think of it like this SQL is like the recipe book.
You okay?
And MySQL is a specific brand of oven. Okay.
Okay, I'm following.
SQL provides the instructions, the recipe, if you will, while MySQL is one type of RDBMS that actually uses those instructions to manage the database.
So there are other ovens out there that can use that same SQL recipe book.
Exactly. There are tons of different RDBMS out there, but SQL is the common language they all understand.
Uh-huh. That actually clears things up a lot. So we've got our database, our DBMS managing it all, and SQL is our way of communicating.
Right.
But what about all the stuff inside those databases? We've talked about tables, rows, and columns, but what about those mysterious fields and constraints?
Right. Let's break down the anatomy of a table a little more.
Okay.
Each row in a table represents a unique record. Let's say information about one specific customer.
Okay.
And the columns, those are called fields.
Fields.
And they hold specific pieces of data for each record. So for a customer, you might have fields for their name, address, email, and so on.
So it's kind of like each row is a separate file folder, and the fields are the labels on the tabs within that folder.
Perfect analogy.
I'm getting the hang of this.
Now, constraints, those are the rules we set to maintain the quality and consistency of our data.
Ooh.
They make sure that the information entered makes sense and adheres to certain standards,
So like making sure no one leaves essential fields blank or accidentally enters a phone number where a name should be.
Exactly. Constraints are like our data quality control team.
Love it.
A few key ones to remember. Primary key acts like a unique ID for each record.
Right.
Foreign key creates links between tables based on shared information.
Okay.
And not no-null makes sure certain fields can't be left empty.
Those are definitely important for keeping things organized and accurate.
Yeah.
But let's say we have information spread across different tables, like customer data in one and their order history in another.
Right.
How do we connect those pieces to get the full picture? You mentioned joins earlier, right?
That's where the relational part of RDBMS comes into play. Joins let us combine data from multiple tables based on their relationships. It's almost like merging different spreadsheets.
Okay.
And the most common type is the inner join, which only returns the matching records from both tables.
So if I wanted to see which customers bought a specific product, I'd do an inner join between the customer table and the product table, using a common field like customer ID.
You got it. You're picking this up quickly.
Thanks.
Now imagine you have this massive database with millions of records.
Wow.
Searching through all that data could take forever, right?
Yeah, that wouldn't be very efficient. Is there a shortcut or something?
That's where indexes come in. Think of them like the index at the back of a book. They allow the database to quickly locate specific information without having to scan every single record.
Makes sense.
They're essential for speeding up data retrieval, especially in large databases.
So indexes are like creating a super organized filing system within the database itself?
Precisely. It's all about making databases work efficiently. Now, we've talked a lot about organizing data, but what about ensuring its accuracy and reliability over time?
Yeah, that sounds crucial. What happens if the data gets mucked up or becomes outdated?
That's where data integrity comes in, and it's a concept that's more important than it might sound at first glance.
Okay.
It's about making sure the information in our database remains accurate, consistent, and trustworthy. We'll dive into that concept in more detail in the next part of our deep dive.
Ooh, a cliffhanger. Can't wait. Data integrity sounds like the bedrock of a well-functioning database.
You could say that.
Looking forward to exploring that further.
Absolutely.
Okay, so we're back and ready to tackle data integrity. You made it sound pretty intense at the end of the last part.
It is. It really is. It's not just about keeping things neat and tidy.
Right.
It's about trust. You know, think about it. What if a bank had corrupted financial records?
Oh, that's scary.
Or a hospital with inaccurate patient data, like incorrect allergy information?
Yeah, that's a big deal.
Inaccurate data can have some serious real-world consequences.
Right.
Data integrity is all about making sure the information we rely on is actually reliable.
Wow. Yeah, that puts it into perspective.
Yeah.
So how do we actually ensure this data integrity in a database? Like, what are the steps?
Well, there are a bunch of techniques, but at its core, it's about maintaining accuracy, consistency, and reliability over time.
Okay.
And, you know, those constraints we talked about earlier.
Right, like those primary keys and not NLL things.
Exactly. They play a big role in this, making sure data is entered correctly and follows the rules.
So they're like the first line of defense against bad data.
That's a good way to put it.
Yeah.
Then you've got things like validation rules, which check the data against specific criteria, and data cleansing processes to identify and correct any inconsistencies that sneak in.
So it's like a multi-pronged approach to keep the data squeaky clean.
Exactly. But you know, all this clean data is only useful if we can actually do something with it, right?
That's true.
Yeah.
So what about retrieving and manipulating information from the database? I know we talked about SQL earlier, but I'm ready to go deeper now.
Well, you're in luck because the real workhorse of data retrieval is the select query.
Select query.
It's how we ask specific questions and get back just the information we need.
So it's like saying, hey, database, show me all the customers who live in a certain city, or give me a list of all the products sold in the last quarter.
Exactly. And SQL gives you a ton of flexibility to fine-tune those queries. You can use the where clause to filter results, the order why clause to sort them, and so much more.
It's like having a superpowered search engine just for your database.
That's a great way to think about it.
I'm feeling like a SQL detective now.
Mm.
But our source material also mentions subqueries and views. Are those just like fancier types of queries?
They're definitely a step up, but incredibly useful. Think of a subquery as a query within a query.
Okay, a query within a query.
You use them when you need to filter data based on the results of another query. It can get a little tricky.
Maybe an example would help my brain wrap around this.
Sure. Let's say you're trying to find all the students enrolled in a specific course, but you only have lists of student IDs and course names in different tables.
Okay, I'm following.
A subquery would first find the course ID that matches the course name and then use that ID to filter the student enrollment table.
So it's like a two-step process to zero in on exactly what you need.
Precisely. Subqueries are great for those really specific data digs. And then we have views.
Views, okay? Are we talking about scenic ocean vistas here?
Uh-huh, I wish. In the database world, views are like virtual tables. They give you a customized way to look at data without actually changing the underlying tables.
So it's like creating a specific lens to look at the data without altering the data itself.
That's a perfect analogy. Views are fantastic for simplifying complex data, focusing on specific subsets, or even improving security by limiting what certain users can see.
Okay, I'm seeing how views can be pretty handy. Now, there's one key word from our source material that we haven't discussed yet: normalization. What's that all about, and why should we care?
Normalization is all about efficiency and reducing redundancy. It's like this, you wouldn't store the same information in multiple places in a filing cabinet, right?
Right, that would be a nightmare to keep track of.
Exactly. It'd be a mess to update and keep everything consistent. The same idea applies to databases.
So normalization is like making sure each piece of information has a single source of truth.
Exactly. And by reducing redundancy, normalization makes updates faster, eliminates inconsistencies, and ultimately makes your data more reliable.
Normalization is definitely climbing the ranks of my favorite database concepts. It's like a ripple effect making everything better.
It really is. But let's face it, sometimes we need to get rid of data, either because it's outdated or we just don't need it anymore. What are our options for data deletion?
Yeah, how do we handle that?
Well, SQL gives us a few powerful commands for managing data removal: delete, truncate, and then there's the more dramatic sounding drop.
Ooh, drop sounds kind of intense.
It is. It's like hitting the delete button on an entire filing cabinet.
Whoa, okay.
It completely removes an object from the database, whether it's a table, a view, or something else. All the data, the structure, gone, poof.
So delete and truncate are like the less extreme options.
Exactly. Delete lets you remove specific rows from a table based on certain conditions. It's like selectively removing files from a folder.
So I could delete all the customer records from a specific city, but I'd still have the table itself and the rest of the customer data.
Right. And then there's truncate, which removes all rows from a table, but keeps the table structure intact. It's like emptying a folder without deleting the folder itself.
Okay, so delete is for targeted removal, truncate is for wiping the slate clean while keeping the container, and droppy is for total annihilation.
Got it.
We've talked about adding, retrieving, and deleting data, but what about analyzing it and getting some actual insights?
Ah, you're thinking like a true data enthusiast. And that's where aggregate functions come in.
Aggregate functions, okay.
These functions allow you to perform calculations on groups of values and return a single result. They're like a built-in calculator for your database.
So instead of staring at a huge table of data, we can use these functions to get a quick summary or a key takeaway.
Exactly. Some of the most common ones are AVG for calculating the average, count for counting records, MIN for finding the minimum value, max for the maximum, and SUM for adding values together.
So I wanted to know the average age of all my customers. I would use the AVG function on the age column.
You got it. Aggregate functions are incredibly useful for summarizing data and getting those insights. But there's even more to explore in the world of databases. Are you ready to dive into some more advanced techniques?
Oh, absolutely. I'm feeling pretty confident in my database knowledge so far, but I'm always up for learning more.
Okay, so we've explored a lot of database territory, right? We've talked about how to organize data, how to keep it clean and consistent, even how to, get rid of it when we need to.
I've covered a lot of ground.
But something tells me there's a whole other level of database magic that we haven't even touched yet, like the really advanced stuff.
Well, you're right. Now that you have a good grasp of the basics, we can dive into some of those more advanced tools and techniques.
Okay, I'm ready. Let's do it.
All right, so let's start with something called stored procedures.
Stored procedures, okay?
Now, imagine you have this super complex SQL query that you need to run all the time.
Right.
Instead of typing it out every single time, you can create a stored procedure. It's basically like a prepackaged code module that you can save and reuse whenever you need it.
So it's like a shortcut for a really common task. That's a great way to put it. Stored procedures not only save you time and effort, but they also make your code more reusable and can even improve security by controlling access to sensitive data.
So many benefits.
There are even different types of stored procedures, like recursive stored procedures, which are pretty cool.
Recursive, what does that mean?
Well, a recursive stored procedure can actually call itself.
Call itself.
Yeah, to perform repetitive operations until a certain condition is met. It's kind of mind-bending.
Okay, my brain needs an example for this one.
Sure, imagine you're building a family tree in your database.
Okay, I can picture that.
You could use a recursive stored procedure to automatically trace lineages, like starting with one person and going up or down the generations, stopping only when there are no more parents or children to connect.
Wow, that's actually really clever. So it's like automating that whole tracing process.
Exactly. Recursive stored procedures are super powerful, but I'll admit they can get a little complex.
Yeah, I can imagine. But switching gears a bit, our source material also mentioned creating empty tables with the same structure as an existing table. Why would we want to do that? It seems like making a duplicate for no reason.
Sometimes you need a temporary table for testing or analysis, but you don't want to mess with the actual data in the original table.
Right, like a safe space to experiment.
Exactly. Or maybe you want to archive data while keeping the original table structure.
Okay, so it's like creating a blank canvas, but with the same dimensions as your original painting. You can play around without ruining the masterpiece.
I like that analogy. And there's a neat little trick to do this. You use the into operator with a where clause that's always false.
A where clause that's always false. What does that do?
It tells the database to copy the table structure, but not actually insert any data. So you end up with an empty table that's ready to be filled.
That's pretty slick. I love these little database hacks. What other tools or techniques should we have in our database toolkit?
Let's talk about pattern matching. It's like doing a Google search, but for your database.
Okay, tell me more.
You can use wildcards, which are spatial characters that represent any character or sequence of characters, to find records that match a certain pattern.
So instead of searching for an exact name, I could use a wildcard to find all customers whose last names start with Simum, for example.
Exactly. It gives you a lot more flexibility when you don't know the exact values you're looking for.
That's super useful. I'm feeling like a database detective now, using clues and patterns to track down information.
I like it. And speaking of text and characters, there's another concept called collation that's important to understand.
Collation. Okay, what's that all about?
Collation is all about the rules that determine how data is sorted and compared, especially when you're dealing with text that might have different characters, accents, or case sensitivity.
So it's like setting the language preferences for the database, making sure it knows how to handle different characters and sort things correctly.
That's a great way to think about it. It ensures that data is sorted consistently no matter what language or character set is being used.
That makes a lot of sense, especially in a globalized world where we're dealing with data from all over the place. Now, there's one last term from our source material that I'm curious about: user-defined functions. What does that mean exactly?
User-defined functions are basically mini programs that you can create within the database to extend its functionality.
So we can actually create our own custom functions.
You got it. It's a way to encapsulate complex logic or calculations that can be used over and over again.
So if I find myself doing the same complicated calculation repeatedly, I can create a user-defined function to simplify things.
Exactly. They can save you a ton of time and make your database code more organized and efficient.
Very cool. Okay, before we wrap up, there are two more concepts from our source material that I want to touch on, just briefly.
Okay, sure.
OLTP and OLAP. I know they stand for online transaction processing and online analytical processing, but what do they actually mean in practice?
So think of OLTP as the system that handles all the day-to-day transactions of a business, like processing orders, managing inventory, or updating customer information.
So it's all about speed and efficiency, keeping things running smoothly.
Exactly. OLTP is like the heart of a business, constantly pumping data to keep everything moving. Now, OLTP is a bit different. It's more focused on analyzing huge amounts of data, often historical data, to find trends, patterns, and insights.
So OLTP is about keeping the business going, and OLP is about understanding where it's been and where it might be headed.
You got it. They have different purposes, but both are essential for making smart decisions in a data-driven world.
This has been an amazing deep dive. We've gone from basic definitions to some pretty advanced concepts, and I feel like I've learned so much about the power and complexity of databases.
It's been a pleasure sharing this journey with you. And remember, this is just the beginning of your database adventure.
You're right. There's always more to learn and explore in the world of data. And to all our listeners out there, thanks for joining us on this deep dive. Keep asking questions, keep exploring, and most importantly, have fun with data. Until next time.